You're listening to Setting Course, an ABS podcast. Join us as we navigate the latest trends, developments, and challenges facing the rapidly evolving maritime and offshore industries. Catch every episode at www.eagle.org and podcast platforms everywhere. Hello and welcome to the show. I'm John Snyder, managing editor of Riviera Maritime Media, and I'll be your host. Today we're going to discuss developing a regulatory framework for maritime autonomous surface ships with Joseph Gardemal. Joseph is Regulatory Affairs Manager for ABS. Joseph, welcome to the show.
Hi, John. Thanks for having me here.
Well, first and foremost, Joseph, what is driving increased interest in autonomous surface ships?
At the time, it's an interesting time for the subject. There are really two things driving the interest. One of them is that we're getting very close to the first version, a non-mandatory version of a code for the certification of autonomous surface ships for international operations, the IMO's MASS code, which itself represents the countries of the world coming together and saying that if ships with autonomous capabilities are going to operate internationally, here is how we all agree to categorize them and confirm their performance, which goes a long way towards creating regulatory certainty in people wanting to make investments in these technologies. And the second thing I think is driving interest, it may simply be the progress being made in other industries with regard to autonomous functions. We see around us examples of both government and public applications of autonomous functions, from aerial drones to self-driving road vehicles. And seeing those things, I think, makes it easier to envision an application for commercial shipping. And I think that people becoming more familiar in general with how autonomous systems are trained to operate and make decisions, the way that you would present a software with scenarios, show it human-made decisions, and then allow it to interpolate between all those data points. When it comes across a novel scenario, that's the type of knowledge and kind of mainstream general information that helps people see the feasibility of autonomous function in ships.
Now, of course, when folks think about autonomy, they think, of course, the total replacement of seafarers, and but there's actually various levels of autonomy, and how would that affect the roles of seafarers if such autonomy comes about?
Yeah, so at least from the IMO's perspective, when they set about their work organizing their views on autonomous ship operations, it's a bit intuitive in the way it aligns with what you would expect for the eventual handover of duties from seafarers to automated systems. There are 4 defined degrees of autonomy. So a ship, by its functions, that is becoming increasingly autonomous. Degree 1 is simply ships with automated processes that support decisions being made on board. And there are many vessels with different types of monitoring systems or course keeping systems that help the crew on board make decisions. That's pretty commonplace already today. Degree 2 is a remotely controlled ship with seafarers on board to monitor these types of things. And then the degree 3 is a remotely controlled ship with the seafarers removed, working in a remote operations center. And then the 4th degree, the full autonomous ship, is where systems are in place to where the ship, programmed with some intelligent logic, is able to make decisions on its own in terms of its operations, its navigation, and operate independently that way. And so the effects on these levels of autonomy on seafarers, it's a bit intuitive as well. Generally, the seafarer does less in the areas where the vessel itself can do more. And the role shifts towards monitoring of the systems as they carry out their functions, whether that monitoring takes place on board or from a remote operations center. It's the type of thing generally that it does transform the seafarer's role in a way. It doesn't remove them from the process, but it requires more of the seafarer in terms of skills that they may not have today, the average seafarer, in terms of being familiar with autonomous system functions and knowing when they're operating correctly versus incorrectly. But it is going to require a new skill set for the modern seafarer.
So certainly future seafarers are going to be much different than they are today.
Yeah, a bit more tech savvy, I'd say, to begin with. But again, these systems, the more road experience we have with them, the more confidence people have in them, and more case studies of their successful or unsuccessful operations where human intervention is needed. All of it adds to the collective knowledge of the maritime industry about how to best prepare a seafarer for working on these ships that are becoming increasingly autonomous.
Now, Joseph, you mentioned earlier about the IMO mass code, and what are some of the things they are tackling in this code?
Yeah, so the IMO mass code, well, first and foremost, what it's been set up to do is complement the existing set of IMO instruments governing vessel operations today. So it doesn't necessarily replace any codes. It doesn't replace SOLAS or MARPOL or the IMDG code or LSA code or any of them. It's meant to complement them and provide a pathway for acceptance of equivalencies. In other words, it goes a long way to define goals. It's a goal-based document, essentially. It defines goals in various aspects of ship performance and ship operation, and a list of functional requirements that must be met, which are, after years and years of deliberation, are very particularly defined to be in equivalency to the functional performance of a vessel complying with the standards that is not autonomous. And so, everything from fire and life safety to ship stability to cargo operations, navigation, safety, radio communications, all of it is addressed in the degrees of autonomy under the mass code.
Now, do certain flag states have a kind of a leg up on this? Have they developed their own regulatory framework at this point, or are we too early in the process?
So this is, I think, you could say for the last several years that what began the process at the IMO of developing the mass code was these individual flag states, being pressed by industry to come up with ways to create a regulatory pathway for use of these technologies. The technologies have been developing. They, have proven success in limited applications, in coastal applications for sure. And so it was these, initial local flag state discussions that promoted discussion at the IMO. A collective of flag states uniformly proposed to the IMO that we should develop a code that can address autonomous function on ships operating internationally. And then from that point, I think the effort of most countries has been behind development of the mass code. This is the venue to have your say. If you are a regulator and who would be dealing with ships of varying levels of autonomy in the future, all of the effort I think is being put into this international standard that will really be a unique standard in its own right. Not just unique for the topic, but unique for the IMO's normal method of creating regulations. It will give a lot of flexibility to the types of technology that can be used because they're going through essentially a first principles analysis of every IMO code and convention. What is the objective of every chapter of SOLAS? What is the intended outcome of every part of the LSA code? And how do we ensure that an autonomous vessel is meeting by an equivalent standard each of these intended outcomes from the traditional regulations?
It seems like a really complex topic, particularly when you're kind of moving sort of an international handoff when you're going between two different flag states or coastal states, I guess.
Yeah, I think the mass code itself as an international standard, it will go a long way to putting everybody in the same frame of mind, you could say, when it comes to autonomous shipping. And I think what you're talking about, it really is still a little bit of a gray area. That last mile of transport, when it comes to entering a port, you are essentially within the jurisdiction of a single country. How does that country want to treat autonomous ships within its own ports? Before the mass code, it was anybody's guess really, but I think the creation and the entry into force of a mandatory mass code, when that eventually happens, it will put kind of a unifying view of what the capabilities of these ships are expected to be and what they can be permitted to do in the ports of an individual country. That's something that still it does lie ahead to define.
What's the timeline, I guess, for the draft of the mass code?
Yeah, so I think when we're talking about the timeline, one thing that's important to appreciate is how long it's took and how meticulous really the work has been to lead up to this mass code. The first suggestions of it at the IMO were back in 2015. It was a single information only kind of submission from the United Kingdom saying that as a flag state, as a coastal authority for our own waters, we're beginning to look into domestic requirements for autonomous ship functions. And we think it might be wise for the IMO to do the same for international standards. And then 2 years later, in 2017, a collective of member states proposed to the IMO, we need a dedicated work item for the development of a unifying code for autonomous ships in international service. And as kind of a stopgap, in 2019, the IMO put out interim guidelines for mass trials because this was the IMO's attempt to get ahead a little bit of all of the tinkering around with autonomous functions that many shipbuilders were trying out to see just how good these technologies were. The IMO put out some guidelines for how to safely conduct trials of autonomous ship functions. And then in 2021, just a couple of years ago, they completed their regulatory scoping exercise, which in itself is the roadmap for the MAS code. It takes a first principles look at every major IMO code and convention and identifies the holes you would create if you, by degrees of autonomy, removed humans from the process of ship operations. But so that regulatory scoping exercise set the map, and now this path that we're on to completion of a MAS code is basically the collective best efforts of the IMO and collective knowledge of all the member states of how they would see autonomous ship functions safely implemented into operations.
So an extremely complex process, more than 10 years in the making.
Yeah, just about. By the time a mandatory MAS code goes into effect, which for right now, it's something, a mandatory version of the MAS code should be adopted in 2026, and then entry into force by whatever means the IMO comes up with to make this a mandatory approach for MAS functions. That would be in 2028. But again, you have to appreciate that it requires the IMO to look top to bottom, every aspect of all of the codes and conventions they ever created, and undo something that was fundamental about all of these, which is the assumption that people were around on these ships. There are degrees of autonomy, but they're building this to be a forward-looking code, the MAS code, for the eventual day when these systems are reliable and trusted enough to where people decide you really don't have to have seafarers on board, even for internationally sailing ships. And the autonomous functions are successful enough that can become a new normal for vessel operations. So has been a long process. It is a complicated problem, but the end the end goal is more in sight now than it has been ever before. So
interesting. Now, of course, as you pointed out earlier, the general public is certainly familiar with autonomous functions right in their vehicles, parked in their driveways. And so it seems like the technologies to enable autonomous ships might be more advanced than the regulatory framework.
Yeah, you could say that. This is, kind of a situation where the technologies, in some cases, they do outpace the regulations. And now, the IMO is setting up a regulatory framework that will last throughout new developing technologies by creating a goal-based framework for these degrees of autonomy and clearly defining, by whatever means an autonomous function is created, what measures of its success should be. So yeah, we're all familiar at this point with, cars that have different levels of self-driving ability, whether it's a simple cruise control in your vehicle or if the car itself is able to navigate city roadways. And just that, firsthand experience that more and more people are seeing in daily life, it demystifies it a little bit, I would say, and makes it seem like autonomous shipping is something that we should definitely have. If we have other forms of autonomy, why not autonomous shipping?
Right, right. Now, Joseph, what are some of the technologies that are going to enable autonomous ships?
A lot of the last 5 to 8 years, when we talk about these mass trials of different different technology platforms coming over and finding test beds in existing vessels and seeing how they react to the environment, it's been really to figure out what combinations of sensors, of environmental observation tools are the best for informing autonomous decisions in navigation, especially whether it's traditional radar or lidar, or utilizing some of the instruments that are already on board these ships to inform a software that can then make navigational decisions. Some service providers are coming up with their own platforms, with the eventuality being that these ships are controlled remotely. You would need a user interface that substitutes for the captain's chair, essentially. So these novel solutions are coming up, very different from each other, but all oriented towards the same goal. But behind this, I think another technology that will enable autonomous shipping is improvements in vessel communication, VDES, VHF data exchange systems. It's a type of technology that utilizes something that's a very reliable form of communication, VHF radio communication, but essentially putting a software control interface to it so that the VHF radio bandwidth can be used much more efficiently. And it allows for a higher volume of data exchange that probably in the future autonomous vessels are going to need, whether they're exchanging information rapidly with shore-based services or vessel-to-vessel communication especially. And then behind that, supporting it is simply improvements in satellite communication so that data can be exchanged from vessel to data servers to remote operators and have confidence that your control of the vessel, your observation of the vessel is for all practical purposes in real time. These types of technology changes coming together at the same time really is what's going to enable autonomous shipping.
Now, of course, one of the concerns about using autonomous vessels is in regards to potential collisions and groundings, or of course, there's also the cybersecurity risks of perhaps either disabling a vessel or hijacking an autonomous vessel. What kind of regulatory safeguards are in place for all those things, Joseph?
Yeah, so what I would say to those types of concerns is, first we have to acknowledge that these types of hazards, potentials for collision and groundings, piracy, cybersecurity, these hazards exist whether a vessel is fully manned or fully autonomous. And there are regulations and other guidance that exist to try and safeguard vessels from these types of hazards. And when it comes to these degrees of autonomy, this is where the mass code tries to fulfill its intention of setting a goal-based approach with defined functional requirements to lead to equivalent outcomes, whether you're manned or autonomous. So these types of subjects, avoidance of collisions, avoidance of groundings, these are things that are rolled up into the mass code to, one, clarify the intention of the regulations as they stand today, and provide a list of functional requirements that an autonomous system can be designed around. To know that the autonomy that you're designing meets the same type of performance standards that a manned vessel would be held to today. And so the solutions will be kind of tailor-made for autonomy, but the outcomes will be, that are eventually reached will be equivalent.
And certainly, of course, safety and risk mitigation is central to ABS's mission.
Yes, of course, and the types of services and guidance that ABS offers when it comes to autonomous vessel design for cyber-safe vessels. These services and verifications are also developed in mind with autonomous systems, with the idea being that as a class society ourselves, we would hold autonomous systems to the same standard as traditional vessels are today. The hazards don't change, but the operations do. We have to maintain that level of safety going forward, no matter what.
Joseph, give us an idea of, I guess, some of the pilot projects out there right now, and if there's any lessons that can be garnered from these projects to advance the regulatory framework.
I think there are some pilot projects out there that have definitely inspired the regulatory framework that's being developed now. I think the one most people are familiar with is the Yara Birkeland in Norway, fully autonomous and electric container carrier. It is in coastal service, so it's port-to-port autonomy, but operates without a single person on board, and has been doing so for a few years now, I think, and demonstrates kind of what an internationally sailing cargo ship could be. That in principle, that this operation is possible. It's just a matter of creating that sense of regulatory certainty and a clear path forward for compliance that ship owners would need to invest in this type of a technology. And there are other a little bit smaller scale mass trials that have taken place in the last few years, several of them in the coastal waters of Japan, the Mikage, an unmanned ship, making 500 nautical mile coastal voyages, making deliberate efforts to be as unmanned as possible, even going so far as using drones to drop mooring ropes over the side once it's at the dock. The use of a drone on an autonomous ship, and other types of testing going on in the coastal waters of Japan. The Suzaka autonomous navigation systems being tested there, and in Singapore as well. Harbor tugs, with autonomous functionality have been tested in several cases, both for remote operations and autonomous navigation. So these test cases pop up, and generally they are successful. The means by which intelligent navigation systems are operating is getting better and better, and especially in the most congested part of a voyage, which is the port approach. So the operations there are being proven, and so I think internationally operating autonomous vessels should be the natural next step.
Well, it sounds like quite a number of pretty exciting projects. And as you highlight, of course, operating within a port, there are certainly a lot of targets to keep track of.
Yes, and but every instance of this, it adds to the collective knowledge. So all of these test cases, they inform the way that those countries, monitoring those test cases in their coastal waters, they learn from these projects, and then they take their knowledge to the IMO to inform the development of something like the mass code. And so that's how all of these test cases around the world contribute to the standard that becomes the international way of understanding and governing autonomous shipping.
Now, Joseph, with just a few minutes left in our podcast, I was hoping you could share with us your outlook for the advancement of maritime autonomy.
Well, in terms of an outlook, I think there are elements of optimism in the future for autonomous shipping, as well as a few elements of uncertainty. Like I mentioned just a bit ago, one uncertainty that I think still has to be felt out is, that last mile of regulatory compliance. When you're entering the venue of being in a jurisdiction of a single country where one governing authority has, full control of what takes place in its ports, as they should, how will they determine how autonomous ships are allowed to function? Would an autonomous ship require pilotage? Would an autonomous ship be permitted to go all the way to the dockside and moor itself? Each country will have to make these decisions on their own. But the good part about that is all of these same countries are contributing to the mass code right now. I think in terms of a hopeful outlook for autonomous shipping, there is this, I think it's a good potential intersection of mass regulations and decarbonization in shipping, which is another substantial topic, taking up years of discussion to get to the right solutions at the IMO. When we create this environment for optimization, the way you do when you make something autonomous, it creates an environment for how to optimize it, how to make it work most efficiently. And optimization typically leads to improvements in efficiency, and if ships become more efficient because they're autonomous, then not only would you have created this entire new mode of transport in autonomous shipping, but you're also contributing to those goals the IMO is supporting for reduction of greenhouse gases, for reducing the global footprint, the carbon footprint of the maritime industry as a whole. So if the solution for one contributes to the solution for the other, I think that's probably the best outcome that the IMO could be aiming for right now.
So autonomy could then be yet another tool in the toolbox to tackle decarbonization.
I think so. I mean, once you create these systems that rapidly perform analysis of how a vessel is operating in real time, you introduce different parameters for optimizing for energy performance, or energy efficiency performance rather, and then you have this entire new system directly impacting the carbon footprint of a vessel as it operates. And not only that, but then there are the knock-on effects of, once more and more aspects of a vessel's operation become autonomous, if you need fewer people on board, there's potential, weight savings in not needing as large of a crew accommodations footprint to support so many people on board. And so that further makes the vessel more efficient, use its fuel more optimally. And there is we will probably find out in years ahead just how far things can go with a vessel autonomy contributing to vessel energy efficiency. I'm sure we'll find out in the years ahead.
Thank you, Joseph, for your great insight. And thanks for joining us today on the show. Thank you for joining us today on Setting Course, an ABS podcast. If you're interested in learning more about today's topic or listening to more episodes, visit www.eagle.org.